Hello everyone, I think I'm live. I'm pretty sure I am now live. I'm just gonna have a check before I start streaming. Just a second. Mm, yep, I am live. Second. Alright, cool. Uh, this is gonna be the third part of the neural network framework building. Uh, I had taken a bit of a break, as you all might have seen, and the reason was I had a couple of very important things that I needed to tend to, and so yeah, I couldn't really record stuff. I wasn't able to work on anything else. I had some very important things, they are now taken care of. uh, so yeah, today I'm gonna be going over this. So the best way that I think I can approach this is if I can just go over the book that I had mentioned in my previous video, Mathematics of Machine Learning, and I'm basically gonna try to go over some of its chapters in order to kind of understand the math a bit more better, because I feel like it will help me out a bit more. So that's kind of like the game plan that I have. But yeah, that's basically my approach to this. If you guys think of a better way, you can just let me know. Yeah. So let's just get started. Now, I think I have worked on a little bit of code off stream, but it's basically nothing. And so you guys don't need to worry about not able to follow along. So yeah. So I'm just gonna cd into this directory, and we can just open up. Oops. Alright, cool. uh, Alright. um so let me just go on into full screen mode, and let me just open up this file. Alright, cool. So I have written a little bit of code off camera, I'm pretty sure. I think I've written the mean squared error activation, I'm sorry, loss function of camera. I'm just gonna get rid of it because I didn't want to do that right now. I'm gonna move on. I have the entropy loss function written over here, as you can see. uh, and yeah, this is basically what we have over here. uh, so yeah, this is the softmax activation function, sigmoid, danish, sine, ReLU, and flatten. Cool. So here, as you can see, we do have everything in place, which is pretty cool. All right. So now that we have this stuff in place, we can move on to. I'm not gonna have like a bunch of loss functions right now. I think I'm gonna try to add binary cross entropy today, I think. And yeah, so binary cross entropy loss function class binary cross entropy, because I feel like that's one of the more important loss functions when you're going to be doing binary label classification. In such cases, using something like binary cross entropy is obviously going to be very crucial. And so yeah, so let's pull up the equation for binary cross entropy. So I'm just gonna open up Google Chrome. Alright, there we go. And now we can just go ahead and search for it. Binary cross entropy loss function formula. There it is. Alright. So in mathematical annotation, it's the absolute of the y prediction minus the y actual. Makes sense. Skip that. So if you have this, what should we do? Log of the corrected probabilities. Alright, I kind of get it. I kind of got it. So we are doing this, using this in order to get this, and then we are doing this. I guess that's what's happening. So the way I think I can really approach a problem like this is if I basically write down the math that I'm doing. I think that could be a good way to kind of do this stuff. All right, so let's look into this. I want to look into the equation for binary cross entropy. For now, I'm gonna keep this article aside. Not that one. Let's look up this one. Two categories only make sense. Alright, so this equation obviously is a lot different. Therefore, likelihood or desire, in this case probability of I got a 4 in the category which we want to minimize, maximize. Alright, the PMF. Alright, so that's the probability mass function. I think this is what we want. Yeah, I think this is what we want. So we want something like this. We want the negative log likelihood. I'm pretty sure. Wait a second. Well, so first off, yeah, we are looking at the metrics of a function we can use to optimize our model performance. The loss function tells you what your model is in its predictions. If the model predictions are closer to the actual value, then the loss is minimum and they're different than the maximum. So it's absolute of y pred minus y actual. Makes sense. On the basis of the loss value, you can update your model to get the best result. Binary cross entropy is the negative average of the log of corrected predicted probabilities. Alright, I think I get it. So if it is the negative average, alright, so I kind of sort of understand of what it is that they're trying to talk about. Now, if you're talking about average, I am assuming that they're talking about a summation somewhere. So if I open up something like Notion, I don't know how to use Notion, but I've seen a lot of people use it. Can I just not log in? Try Notion free. Because I do want to try to kind of document this stuff. I could do it in a book, but I do want you guys to see this stuff, so that's why. For now, I'm just gonna do it on a Google Doc. Alright, it's taking way too long. I know, not the best thing. I probably should use LaTeX, but I'm not gonna use that right now. I'll probably format it in LaTeX later on, but for now, not this one. I'm just gonna name this neural network. Alright, cool. So first off, we're gonna look at binary cross entropy. So when we are looking at binary cross entropy, um, okay, binary cross entropy, uh, we can just make use of that definition to form an equation. I feel like that should work. So just a second, I'm just gonna make this a heading real quick. Just gonna do that. So if we can just say that binary cross entropy is, what was it? The negative average of the log of corrected predicted problem is the negative average of the log of the corrected predicted probabilities. So makes sense. So I think what they're trying to say is you're gonna have a output sigmoid, and then you go so I think what they're trying to say is, so you're gonna have a forward propagation, you're gonna move to your output layer, you're gonna do the softmax pass, and once you reach the output layer, you're gonna back propagate back. You're gonna have your loss, and then you will obviously tweak your weights and biases using some optimizer, maybe Adam, maybe RMS prop, and then you will forward propagate again. I think that's kind of sort of what's going on. So according to me, if it's the negative average, let me just insert the equation over here. So if that's the case, if we have, so if I have to have it as L of x, that should be equal to the negative average. So the first off, if it's an average, it's got to be a 1 over n, and n is going to be your sample size. So it has to be something like 1 over n, and it's average, so it has to be a summation, because without that's not gonna work. So it's gonna be like n equals 0 to like, I don't know, I equals 0 to like I don't know, L no J, and in here we can just say like, I don't know, it was what, the negative average of the log of the corrected probabilities. So if we look at this one, it's absolute of y prime minus y actual. So we gotta add these, and I'm gonna do it y, I'm gonna do it like this, y sub I minus how can we do y hat? I'm gonna see that. Oh yeah, we can have that. And y hat sub I, if how I interpreted this is correct, then that was correct. Alright, cool. Is this the equation? I don't know. I think this should be the equation. It's supposed to be 1 over n. Like, I just can't think of another. I don't know. Like, I just can't think of another equation to this. I just think that this has to be correct, hopefully. So because we have the absolute, also it's the negative average, right? So it has to be a negative there. Alright, so if we look at this one, we're doing something like this. We're getting the negative log likelihood, and then we mean it. I'm sorry, we find the mean for that. Alright. So when you do the log of the corrected probabilities, uh, the reason is that log offers less penalty for small differences. Here we have the calculated values. Since all the collected values are negative, in order to compensate for the negative log, we will use a negative average. Oh, alright. So what they're trying to do is uh, they are just trying to do log of the alright, so it's not this, it's something a bit different. It's just gonna be log of pi. I think it makes sense. And yeah, this should be j, this should be n. Actually it can be j, but we gotta keep a little bit of ease of conventions, so this has to be n. Alright, cool. So pi obviously is gonna be your probability that you have. So the way we're gonna do it is we gotta figure out pi first. Pi in this case is just gonna be the log of the predicted probabilities. So I think in the forward pass for binary cross entropy, we're gonna have self predicted probabilities. I don't know how to spell this. I think that's how you spell it. And what do we have to do? We have to find out the log. So we can just say I can just call it prob log is equals to np dot log predicted. You know what, I'm just gonna copy it because I know I'm gonna make a spelling error and I'm gonna waste a lot of time on it, so it's just good to do it like this. So prob log is gonna be a negative value, so we gotta find out the absolute value to it. Makes the most sense. Alright, so are we doing, oh okay, so we are not doing it with an absolute, we are just multiplying it by -1. The same thing, to be honest. So alright, cool. Well, oh alright, so we can actually do it in two ways. Alright, so in this case we can finally say binary loss val, and we can just call it -1 over n. N in this case it's just gonna be your it's gonna be your data size. Really, it's gonna be your length of the data. How do I do that? Data I'm just gonna say n over here. Actually, no. I'm gonna say like data len. Actually, let's not even do that. We can just go ahead and say data. We can just take in the data, and we can have n as the len of the data, and then we can do a negative 1 over n. We can just put that in a bracket over here, times it's the np dot sum till n. Sum till n, that doesn't really matter, because actually I think that does. No, that doesn't matter, right? Because yeah, we can just do the log of pi. Did we do log? Yeah, we did do log. So that's just gonna be log. Hopefully that's correct. That should be the required forward pass for the binary cross entropy active loss function. I have no idea how to backpropagate this thing, but yeah, this is the forward pass. Makes sense, I mean, yep. Alright, cool. So let's see if this works. Hopefully it does. I have no idea. Like, I think we're gonna run into some stuff like negative infinities and stuff. But let's see if this does work. I mean, we did spend quite a bit of time on this. Yeah, we spent almost half an hour on this. So yeah, hopefully this works. So we can just say loss 2 is equals to binary cross entropy, and I can say print loss dot forward, and it's gonna take in that output to dot transpose and y. No, this doesn't take in 3 arguments. Y pred. We just need the predicted probability, so we just need the y pred. Then why am I passing in 3? Do I have like a loss class? Something like that? You know what, I'm just gonna pass on this. Alright, let's just pass this in, see if it works. I don't really care. This should work. Oops. Oh, are you kidding me? 938. Mean square error is not defined. Alright, I'm just gonna comment this out. Alright, there we go. Loss is not, are you kidding me? Oops. Please work. Prop log is not defined. Oh yeah, it's prob log, not prop log. We gotta change this. Prop log. There we go. Alright. What is the loss? Do they have like any tests or anything? We do have a loss here, as you can see. We do have a loss. In a way, that's good. Because I have a loss over here. And that's kind of sort of what I wanted. I wanted a loss. Um, you know what? I think we can kind of try to estimate the loss in this one. Because if we run this, if that's the dataset that we are working with, I can see why the loss is high. The kind of data that we are working with, it's why do I have JetBrains open? All right, good. I think it's basically the loss is so high because the kind of data that we are working with, that's not the kind of data you want to work with. If we make the classes 2, I think that should work. We're gonna have to change that, I'm pretty sure, but let's see. Oh, turns out we don't have to change that. Pretty neat. Uh, well, the loss didn't change. That's interesting. It was a 5.7. It's now a 5.29. Um, so if I were to go ahead and make this, I don't know, like do something like that. Actually, I don't think I can do that. I can just do something like this at max. Actually, I think I know why the loss is high. I think I know why the loss is high. I just figured it out. I'm gonna have to undo this stuff. Oh yeah, well the dense 2 is that the output 2 is forwarded on the dense 2. Then we apply binary cross entropy on the output 2. Why are we transposing output 2? Alright, so we are at a 5.29. Is it because we have X? What if this was, I don't know, what? Well, obviously that shouldn't make any difference. It's the Y that really matters. So if I were to just pass in output instead of output 2, so if I just passed in output, would the loss vary? Nan. Oh yeah, that actually should be nan, because we don't have the probabilities yet. Makes sense. Alright, so before we do anything further, I gotta figure out if this is right. How to test binary cross entropy loss test. I really want to check if this is correct or not. I wanna check this. I really wanna check this. Alright, so the first thing is, how can I get the right answer? Output. Alright. Oh, alright. Oh, cool. I get it. We can just do that. Cool. I never thought of that. Alright, so what we're gonna do is, uh, let's just do ipython 3 and let's test this out. So according to TensorFlow, the loss for this should be, drum roll, 5.14. Alright, now if we get this, everything is working, we have a binary cross entropy in place. If this doesn't work, well, then that means we have done something wrong, and that's not good. But you know what? I mean, we make mistakes, it's okay. I think I should do it in a file. I have a file dedicated to this stuff. I never knew I would be writing like kind of sort of tests for this stuff, but yeah, yeah. All right, cool. So we're gonna be basically doing the same thing that these guys have done, like this. This is gonna be the original, and I'm just gonna store this in np loss dot np loss. All right, time for our thing. I'm not expecting it to work, but let's see. All right, so we can just say y true, y bread. Now moment of truth. Let's run this. All right, are you kidding me? If I was 0 encountered, are you kidding me? What are we doing? Well, I'm logging over the predicted probabilities. Oh yeah, I forgot to clip them. All right, let's see. Oh, not this, not this. All right, let's hope for the best. All right, I mean, is it the same? No. Is it very different? No. I mean, it's kind of the same thing. Alright, I think I'm gonna do the from logits to false. Maybe that alters the thing. Alright, so if I just say like from maybe that changes up the output a bit. Because like the output is very similar. However, technically the output should be the same. The fact that it's not the same might be an indication that there's a bug. Either that or there's it's just some accuracy thing that I don't know about. I mean, it's basically the same laws. I mean, yeah. But see, the issue is once it scales, the difference will get too big, and I really don't want that to happen. And so I really want to perfect the loss. However, you know what? We have reached. You know, I want to see what np.clip does. What does np.clip do? Not no clip. Alright, let's have a look. Oh, alright, makes sense. Alright, we're just clipping the array. Makes sense. I had forgotten how I had used this one. Is this supposed to be a negative log? I think this is a negative log. I think no. This can't be a negative log, right? Because when you let me pull up my calculator. When you do a log to the base 10 of a point number, you do get a negative value, and so when you're multiplying it with this negative value, you do end up getting a positive value over here. Alright, cool. So now that we know that, that's good. So now I want to look at one more thing. Do loss functions really need to be back propagated? Do loss functions Alright, so I think what I'm gonna do in this one is in the test that we have over here for the y thread, I'm gonna put in not one, I'm gonna put in some random values 65495. Alright, this should be good enough. Alright, let's have a look. And that is pretty good. Alright, I'm gonna be good with this. And I think if we do make, I think the from logits is what was causing the issue. Don't know what from logits does, but I think that's the real issue. Yeah, I'm pretty sure that was the issue, because when we turn that off, yeah, as you can see, oh, you know what, from logits isn't really the issue, to be honest. I feel like it does work. I mean, if I make one of these, like, see, alright, I'm gonna make like the simplest of tests possible. I'm just gonna make all of these ones. That should give me a loss of 0 on both of these. Alright, yeah, I have a bug. I have a bug. This works. This one works. It's a 0, 0.0. I have a bug in my loss function. Need to figure out what it is. At least I was able to figure out I have a bug. We have the predictor. Is it something related to this? I mean, alright. There's 1 minus 0 0.00000. If I make this something like a 10, does this work out? I mean, not to mention my loss function is not memory management. Okay, yeah, it doesn't. Yeah, there's some issue. So we are clipping it, logging it. What is it that we are not doing correctly? I mean, I'm pretty sure we're doing everything correctly. Alright, you know what? Let's just use this equation. I mean, it's not like, what does yi stand for? I don't know that. At least let me know what yi is. Is it like let me open this up. Oh, I guess pi is the logged, and what is yi for God's sake? Is it y hat I or what? Pretty sure yi is the actual ones. Yeah, pretty sure. So we're gonna do that. So we're just gonna say actual values. Alright, let's just do that. Makes sense. Oops. Alright, now we can just implement this equation in there. We already have the log pi in place right here. So we can just call this pi p sub, I don't know, I'm just gonna call it prob. I'm just gonna comment this out for now. Set the loss value equal to the 1 over n multiplied by np dot sum negative I'm just gonna say like y is equals to actual values. I know not the best practice, and I could have just said y, but yeah. Why are we doing log of pi? That just doesn't make sense, right? Because we are already doing logs for that. Oh, I guess they're just trying to say don't do that. Oh, I get it. So if I just say prop here, and let's put this in a bracket of its own. It's getting a little bit like I always feel like I'm writing in some other language. You know, the number of brackets in here. Now let's test this one out. Oh no, it's gonna run into an error. I gotta modify the test a bit. It's y true y red, and I also have to pass in y true year. Alright, this should work. Then loss. Oh, okay. I think I. Yep, I. Yep, if an issue. I had to pass in y true year in my DIY loss function. Prop is not defined. Are you kidding me? Oh yeah, it's prop. Alright, let's hope it works. Like as oh, are you kidding me? It's still not working. Do I have to log these again? I just don't think that's gotta be the case. I think I could just round it. Something like that. Invalid value entered in low. Yeah. My implementation was correct, turns out. I think I know the error. I think we're going for something a bit too accurate when we can just round it up. So in this one we do understand. If y bread, we do that. NP not mean. Oh, I guess I know that. Y minus log that term 0 term 1 negative np dot mean. Oh yeah, I got it. Um, np dot log. So this is what this guy did. First off, why is he dotting these things? It doesn't make any sense. Alright, so if we replace this with a negative np dot mean, does this work out? No, 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 no. This does not work out. I think I gotta get rid of something. I think I need to get rid of this one negative. This still doesn't work out. I mean, I just can't think of a way. Because our answer is very similar to what should be the answer, except at certain points when there is a discontinuity. Alright, so if we break down what was given in this article piece by piece with what was mentioned in this Stack Overflow post, we should be able to figure the thing out. So it's so this is what is this. Term 0 is y minus y true times np dot log 1 minus. I think I got it. So in this one, we were doing a 1 minus a prob, while in reality we had to do a log of a 1 minus prob. I think they are trying to tell us to do something like this. Oh, I guess I know what they're trying to tell us. So I think what they're trying to tell us is np dot log 1 minus y. I think that's what they're trying to tell us. Nope. No, not y, right? Yeah, it should be 1 minus, what's pi? Okay, pi is the probability of class 1 and 1 minus pi is the probability of class 0. Why is he adding that? I think that's just something that I don't know. Something's wrong. I just ended up making things worse. Alright, this seriously isn't working. Yeah, something's wrong. Can we subtract it? No, we cannot subtract it. You know, I'll get to this a little while later. We at least got very close to implementing this. I mean, we did try our best. I think log pi is the predicted probabilities. So, alright, I'm gonna give it one final attempt. Just one final attempt. If I can get it done, it's good. If I can't, we'll get to this later. Alright, cool. Mean. So we did that much. It's gonna be a so yi can be a y times a log of the pi, which is gonna be our p, which should be this. We add it to 1 minus y times np dot log 1 minus p. Hopefully this works. We're gonna have to add something, the e minus 10 thing, but I think we should at least get a close enough answer. Division by 0 and count it. Oh yeah, we gotta do the clipping the predicted probabilities, right? Yeah, we gotta do that. Oops, I forgot to do that. Term 0 so if we add the and then you add it over here. And where is that? Why should why true why prime why guess it is yeah, it's nearby bread, so I think it's here. All right, there we go. It worked. It finally worked. All right, this is good enough. We're missing a negative somewhere. I'm just gonna throw in like a negative wherever I can. So yeah, just a second. We are missing a negative somewhere, so I'm just gonna add a negative where I can, and hopefully we'll be done. Wait a second. I think this is correct, and we don't even need to add a negative because I think this should be good enough. So if I change one of this to a 0.9, change this to a 0.9. All right. All right, this works. So this works. I'm happy with this. If this works, this is good enough. I think we are missing a negative somewhere. I do think that. What is this? 15 by 424 948 6 if a person wants to perfect it, probably might want to add negative somewhere over here, but I'm not gonna do that. I'm not gonna do any of that. I'm happy with this. There you go, guys. Binary cross entropy implementation, and that is it for today's stream. Hope you enjoyed it. If you did, like, subscribe, comment down below what else you want to see. And we didn't have to open the book today. Good enough. And yeah, I've been going for quite a long time at this point, and I'm a little tired. So until the next time I meet you guys, bye bye.